Alright guys, today we're looking at 2.4a directed graphs. So, directed graphs are graphs that have like arrows that tell you this is the way you must go. So it's more directed. I know that sounds corny, but when an edge has a direction, it's called a directed edge. I know. Earth-shattering news there. Now, see if you can fill in this next one. A graph in which all edges are directed is called a, you guessed it, directed graph. Okay. So a directed graph example, and here's another one of those juicy little examples like our Carolyn's example. Model the following situation with a directed graph. Assume that we have gathered the following information about how rumors spread in the Jones family. So if Manny hears a rumor, he will communicate it to Gloria and Jay, but Gloria and Jay will not tell rumors they hear to Manny. So I'm going to do this in pencil in case we screw up, okay? So we have Manny, and when he hears things, he's going to tell them to Gloria and to Jay. I don't know how many people we're going to have, so I'm going to make this a little bigger. Gloria and Jay. Cool. All right, but they don't tell him anything. So apparently they know that Manny just runs his mouth. It's one of those things where if you want anything told, you tell Manny. Okay, Gloria and Jay will tell rumors they hear to each other. So in this one, these aren't going to be really straight lines because you're going to have to loop them around. I drew this arrow backwards. See? That's why I'm using pencil today. Okay, so this one goes this way. So Jay tells Gloria, Gloria tells Jay. Gloria tells rumors she hears to Cameron. But Cameron does not relay rumors he hears to Gloria, so he doesn't tell her anything. But he does tell them to Jay. All right. And that's how that goes. Okay. Now, I have a question that I'm going to write down right here. If Cameron hears a rumor first, who will not hear the rumor from anyone else in the group? And I'm going to let you figure this one out. So if Cameron hears the rumor first, so it starts with Cameron. Who is not going to hear the rumor? Is Jay going to hear the rumor? Is Manny going to hear the rumor? Is Gloria going to hear the rumor? Okay. The answer to this is Manny will not hear the rumor. And the reason Manny will not hear the rumor, no arrows come into Manny. Nobody's talking to Manny. Manny talks to other people. Okay? Got that? All right. So let's go to our next page. Suppose that X and Y are vertices in a directed graph. If it is possible, and I want to highlight this, if it's possible to begin at X, follow a sequence of edges in the directions indicated, and end at Y, then we call the sequence of edges encountered a directed path. Okay, so if you list out how you went there, that's a directed path. We will denote a directed path by a sequence of vertices along the path. The length of a directed path is the number of edges along that path. Okay? Recall that edges cannot be repeated. Okay? So if we're going A in this particular problem, A, C, D, E. A to C, there's 1. C to D, we can go there, that's 2. D to E, we can go there, that's 3. Is A, B, C, E a directed path? A to B, B to C. Can we go C to E? We cannot get there. So the answer to this one is no. C cannot go to E. Okay? Easy peasy lemon squeezy. Can you find 2 directed paths from A to C? So 2 ways to get to C from A. Okay? So let's do the obvious one. A, B, C. Let's find another way to get there. Is there another way to get out of A? We could do A to F, F to B, B to C, A to F, F to B, B to C. Okay? If you wanted to go all the way around the world, okay? If you wanted to go all the way around the world, you could go A to F, F to E, E to D, D to B, C to B, B to C, excuse me. So we could hit every letter. Are there any directed paths from C to A? Or are there any arrows coming out of C? Yes. So we can go C to B, but can we ever get into A? There are no routes coming into A. So the answer for this one is going to be no. Nothing goes into A. Okay? All right, and then the last question. What is the length of the directed path ABCDB? So, if you look here, we're going from A to B, so this is 1. B to C, that's 2. C to D, that's 3. D to B, that's 4. So the length of that path is 4. And ladies and gentlemen, that's the end of our notes for today. I hope you have a great day, and let me know if you have any questions. Thanks.